Hey guys, this is Jason Matthew from Trinidad and Tobago, and today we're going to be calculating the net charge of a peptide at a particular pH. So the book that I would recommend for this is Essential Biochemistry 2nd edition, and you want to look at chapter 4. Now if you all are hardcore anime fans, you should already identify what font from what anime this is coming from. So please, if you recognize the font and you know which anime it's coming from, please put it in the comment section below. I'd like to see what you'll come up with. Now this is your typical amino acid here. Alright, so all amino acids can be written this way. Now all amino acids will have, let me just get a pen here. So all amino acids will have an alpha carbon, and attached to this alpha carbon will be an alpha carboxylate group, and you'll have an alpha amino group. Also attached to the carbon will be a hydrogen, so all amino acids will have that. So all amino acids will have an alpha carboxylate group, an alpha amino group, a hydrogen. And where all the amino acids will differ will be that they have a distinct R group. Now, from looking at the amino acid, there are three things here that could contribute to the charge of the amino acids. Obviously, the alpha carboxylate group, the alpha amino group, and according to the identity of the R group, that can also contribute to the charge of the amino acid. Alright, so we have two amino acids in this diagram here. So we have this guy here and this guy here. And when the carboxylate group, alright, comes together and combines with the amino group of another amino acid via condensation reaction, so we are losing water here, you get a peptide bond being formed. Alright, so let's do that. So we have the peptide bond, so this here is your peptide bond. Now look at what's happening here. You had a carboxylate group, the alpha carboxylate group of one amino acid reacting with the alpha amino group of another amino acid. Now before they combined to form this peptide bond, the carboxylate group had a negative charge, the alpha amino group had a positive charge. But you realize that once they form the peptide bond, there is no charge there. Alright? So, and this could continue. Like you could be adding a lot more amino acids together and forming several peptide bonds. And what you're going to get is that you will always have a free amino end on one side and you'll have a free carboxylate end. But all the other alpha carboxylate groups, all the other alpha amino groups will be held together in this peptide bond. Now once they combine to form a peptide bond, you realize that they no longer have charges. So the point I'm trying to bring home here is that only at the ends, the N terminus end and the C terminus end, will your alpha carboxylate group and alpha amino groups have a charge. Otherwise they'll be in the peptide bond, so there's no charge. They will not contribute to the charge of the peptide. So let's look at this diagram here now. So in this diagram, we are looking at a peptide that is made up of 4 amino acid residues. In other words, 4 amino acids came together and via condensation reactions, they form 4 peptide bonds. Now look carefully and you should see the 4 amino acid residues. So this is amino acid residue 1, amino acid residue 2, 3, and finally 4. Alright, and you will see that the alpha carboxylate group of one amino acid is going to react with the alpha amino group of another amino acid. Alright, so here we have the alpha carboxylate group reacting with the alpha amino group to form a peptide bond, and that will continue, and in this case it continues until all 4 amino acid residues are connected together via peptide bonds. Now you'll see that at the end, and you'll see here, you have your N terminus N, Alright, and you have your C terminus end. Now by convention, it is always written that for the peptide, on the left hand side, you have the N terminus N is written on the left hand side, and your right hand side, the C terminus N is written. That is always by convention. So all peptides, you would assume that on the left is the N terminus N, and on the right is the C terminus end. Now the other thing that I want you to look at here is that, as I discussed before, the carboxylate group and the amino groups, when they combine together to form the peptide bond, there is no charges there. Only at the ends, the N terminus N will have this NH3 plus, and on the C terminus N, you will have the C double bond O, O minus. Okay, so today's mission, we are to calculate the net charge of a peptide. Now there are only a specific group of things that contribute to the net charge of a peptide, and that is the C terminus N, as we saw before, the N terminus N. Alright, so the C terminus N and the N terminus N is going to contribute to the charge of the peptide. And after that, there are only 7 amino acids that have ionizable groups that can contribute to the charge of the peptide, and that depends on the identity of the R groups. So you'll see aspartate, glutamate, histidine, cysteine, tyrosine, lysine, and arginine. Now on this column here, we are looking at the R groups of these corresponding amino acids, and as you can see, they have indicated the hydrogen that will be lost as a proton. Alright, and over on this side is the pK values. Now when you're doing your calculations, you may want to come back to this table. Now for my class, I don't ask that they remember these pK values. Alright, but for some other teachers, they will want you to remember. So it all depends on your class and what the teacher wants. So please find out if they require you to learn the pK values offhand or not. For me, it's not required. I will give you that in the question. Alright, so remember that C terminus, N terminus, they contribute to the charge of the peptides, and in addition, there are 7 amino acids based on the identity of their R groups that it's possible to give up a proton depending on the pK value. So let's look at the N terminus end. Now we have NH3 plus going to NH2. So it's a +1 charge, alright, from the NH3 plus, and the NH2 will have 0. And that will depend on the pK value. Alright. Now, when the pH is less than the pK value, you have a +1 charge. And when the pH is more than the pK value, you have no charge, 0. Alright. Now, the N terminus pK values, and just like as the table shown before, all those pK values are fixed values. Those are the values for these things. What we are saying is that the peptide will be at any pH. It depends on the pH of the solution that the peptide is in. And if that pH is less than the pK value, then your N terminus N will be NH3 plus. In other words, it will have a +1 charge. And if your pH, the pH of the solution that the peptide is in, if that pH is more than the pK value, then your N terminus will exist as NH2, and it will have a 0 charge. Alright, now, so again, the pK values, they are fixed. They will be given in the question, if it's my class, that is. So those are fixed values. The pH is what's going to change in the question. The pH will depend on what the pH of the solution that the peptide is in. So look out for that, guys. Alright, so out of those 7 amino acids that we identified before, that their R groups could contribute to the charge of the peptide, we are going to be looking at first the positively charged R groups. And there are 3 of the 7 amino acids that have positively charged R groups, and that'll be histidine, lysine, and arginine. Now we're going to tweak the equation we had before with the N-terminus and where it was NH3 plus going to NH2. And now let's say it's NHX plus going to NHX minus 1. And you will see why I'm doing that in the next slide. Alright, so it's NHX plus going to NHX minus 1. Now let's see what I'm talking about. You will see that it's not like the N-terminus where it's always NH3 plus going to NH2. Now, in the first one, we're looking at lysine's R group, and you'll see that lysine's R group has a NH3 plus. So that one is straightforward. So in that case, for lysine, X is 3. So you have NH3 plus going to, and it's NHX minus 1. If X is 3, so this will be NH2. Alright, now remember why exactly you're getting this plus charge. When nitrogen has 4 bonds on it, it gets a plus charge. So in this case, it's 3 hydrogens, and then this 1 bond attached to the carbons. That'll be 4 bonds. Alright, so let's look at arginine's R group. Now in arginine's R group, you see that there's 2 NH2s. There's this guy here, and then there's this one. But be careful, it's this one that it has a plus charge. Now why is that? You have to go back to nitrogen will have a plus charge if it has 4 bonds. If you look at this guy, it has 1, the nitrogen to carbon, and then it has 2 hydrogens there. So there's 2 plus 1 is 3. But this guy, it's nitrogen, and it's 1, 2, 3, 4. So that's 4. So it's plus. Alright, now in that case, alright, if we look at this guy, then X is 2. So it's NH2 plus, alright, and it's going to NHX minus 1. So if your X is 2 in this case, 2 minus 1 is 1. So that's it here. Now histidine's R group is even different. Alright, so this here, if you look, it has NH plus, but again 1, 2, 3, 4 bonds. So this NH plus, alright, and that will go. So then what it means that this nitrogen is going to lose this hydrogen as a proton, and then the nitrogen will no longer have that hydrogen attached. Alright, so that's why I use the formula NH plus X going to NHX minus 1. It's not always going to be NH3 plus. So positively charged R groups, and it's histidine, lysine, and arginine, and it's NHX plus going to NHX minus 1. Now how much hydrogens attached to nitrogen varies, but the concept is the same as the N terminus N. You have plus 1 charge, alright, so that's the plus 1 here, is going to 0 because it becomes neutral, and that will depend on the particular pK values for the R groups of histidine, lysine, and arginine. Now these pK values, as I said, are fixed values. You're going to get them on a table. You may need to learn them according to what your teacher prefers. I'll be giving it as in the question. And what is going to be changing in the actual question is the pH values that these peptides are in. So whatever pH value they give you for the question, you always ask yourself, if the pH is less than the pK, well then it will have a plus 1 charge. But if the pH value that they give you is more than the pK, well then you will have a 0 charge. So we go to the C terminus N now. Now the C terminus N, you're going from the carboxylate group COOH to the carboxylate group COO minus. So if you watch, you'll see that COOH has 0 charge, and your COO minus will have a minus 1 charge, and that will depend on the pK value, a fixed value that will be given. Now again, if your pH is less than the pK value, then it has a 0 charge, and this pH value will be given in the question. So whatever pH the peptide is in, alright, So let's say the peptide is in a solution that has a pH of 5, but then you're looking to see if that pH of 5 is less than the stated pK value. If it is less than the pK value, then the charge for the C terminus will be 0. It will be existing as COOH. Now if your pH value they give you is more than the pK value, well then it has a -1 charge. In other words, the C terminus end of that peptide is COO minus. And that's how you do it. So there are actually 7 amino acids that could affect the charge of the peptide. You have 2 of them that have negatively charged R groups. And those 2 are aspartate and glutamate. So you see here that aspartate's R group is CH2COOH. Alright, and again it's the classic COH. So that is this guy here. So COH, alright, could be like this, or it could be COO minus depending on the pH of the solution. And glutamate, well, at least for the negatively charged R groups, it's pretty straightforward. Both of them have a COOH group, a carboxylic group in this case, which could either be, well, it could be in the carboxylic group as it is right now, or depending on the pH, it could be in the carboxylate group, COO minus. So it depends on the pH of the solution. Alright, and again we are going from a 0 charge to a -1 charge, and it will depend on the pH. So if the pH value of the solution is less than the pK value, it's going to have a 0 charge. And likewise, if your pH value is more than the pK value, well then you're going to have a -1 charge. Alright, so we have covered 5 of the 7 amino acids in the table. Now we are left with the last 2, and the last 2 will be cysteine and tyrosine, and they are polar uncharged R groups, and you're going from XH to X minus. So that's the general formula I will use. Now if you're following up my previous videos, or if you're in my class, you will know that I would normally pronounce cysteine as cysteine to stress that how to spell it will be CYSTEINE, or the 3-letter abbreviation will be CYS. Alright, so cis. Alright, now the reason why I stress cysteine is because when 2 cysteines come together to form a disulfide bond, that's cysteines, which has a very similar spelling. All you do is knocking off the E. So I just stress that. So sometimes you might see this out of habit, I might pronounce it as cysteine, but really the correct pronunciation will be cysteine. Okay, now so it's XH going to X minus. Now if you look, the ionizable group here is the sulfur hydryl group in cysteine, and that's SH. Alright, so that's SH. So it means that your X is S. Alright, so based on the formula there, SH will go to S minus, and you're going to lose that hydrogen as a proton. Now similarly for tyrosine, the ionizable group will be this hydroxyl group here. So in this case for tyrosine, X is O, so you have OH, alright, and we're going to lose that hydrogen as a proton, so it becomes O minus plus, well, the H plus, alright, the proton comes out. So that's it for polar uncharged R groups. And just like with the negatively charged R groups, aspartate and glutamate, likewise you're going from a 0 charge to a -1 charge. Alright, and if you watch your XH it's neutral. So if you watch SH, OH, they're both neutral, so you have a 0 charge. And when they lose the hydrogen as a proton, they become S minus, O minus, which has a -1 charge. And just as before, if you have to look at the pH in which the peptide is in, the solution in which the peptide is in, Alright, and if that pH is less than pK, well then you have a 0 charge. And if that pH is more than a pK value, well then you have a -1 charge. So in summary, alright, you have to consider +1 going to 0 if you are looking at either the N terminus, so you're looking at +1 going to 0 when you're looking at the N terminus, or in your peptide you have positively charged R groups. Alright, and the amino acids that will have a positively charged R group will be histidine, arginine, and lysine. Now you're going to be considering 0 going to -1 when you're looking at the C terminus N, or if in your peptide there are amino acids that have negatively charged R groups such as glutamate and aspartate. Or also look through the peptide, and if you see any cysteines and tyrosine, well then you have to also consider 0 going to -1, and it depend on the pH of the solution that the peptide is in. So I think we are ready to try an actual question. Now I use the word estimate here. Normally you will see calculate the net charge of the peptide, and this is the list of the amino acid residues that will be in that peptide. So that's the primary sequence. Alright, and there are two pHs that we're going to look at. We want to look at the net charge at physiological pH. That's the pH of inside your body. pH 7.4 should be around 7.4. And then secondly, we're going to be looking at the net charge of the peptide, where it's a pH of 5.0. If we're lucky, we're going to get two different answers that are correct. Alright. Now I decided to use the word estimate to stress that although we are doing a calculation, this is still an estimate, and the reason for that is that if you go back to the table there where we're looking at all those different pK values, those are pK values for the free amino acids. So that's when the amino acid that exists as a free amino acid. In the peptide, these amino acids are coming together via peptide bonds. Through condensation reactions they have been formed. Alright, and you have this peptide now, so they are no longer free and single, they are committed. Alright, and the environment in which these R groups are will change. So all of a sudden you have lysine and histidine and glutamate and tyrosine and all these guys who have ionizable R groups. They are not in an environment by themselves. They are in an environment where, according to how the peptide folds, is going to be close to peptide bonds. They're going to be close to other functional groups. Now that has the microenvironment has an effect on whether this R group will lose the proton or not. So while we might calculate the net charge, when we go in the lab, you might see that the actual charge might be different. Alright, this is just an estimation. That's all I want to bring home. And again, it's because the environment in which the R group is in is different in the peptide as opposed to the free amino acid. So that's something to consider. Well, the first thing you want to do is set up a table. And you're going to have 3 columns: group, and then in this case, charge at pH 7.4. That's what the question asks you in part 1. And what's the charge at pH 5.0? So these are the ionizable groups. Alright. So N terminus, alright, and then well actually I put all the amino acids here, right, and the C terminus N. So first of all, remember from the table that I gave earlier in the video that there are 7 amino acid residues that could contribute to the charge of the peptide, as well as in addition to those 7, they have the N terminus and C terminus. It means that any other amino acid present will not contribute to the charge. So if we go through this peptide that we have in the example, you will see that valine, alanine, and glutamine. So valine, alanine, and glutamine, they weren't part of the 7 amino acids that had ionizable R groups, and rightly so, we give them the charge. For valine, alanine, and glutamine, their R groups have a charge of 0. So we already covered that. Now let's look at the N-terminus end. Now from the table that I gave earlier on, you know that the N-terminus end, and from the slides, you know the N-terminus end is +1 going to 0, and the pK value for the N-terminus end is 9.0. Now when this peptide is in a solution of 7.4, we have to go back to this. N-terminus is +1 going to 0, and you have a pH of 7.4. 7.4 is less than 9. It's lying on this side. Alright, consider like if in the middle here is 9. Where would 7.4 lie? It's going to lie to the left. So therefore, at 7.4, you're going to have a +1 charge. Now let's do it for pH at 5. So this peptide is in a solution that is at a pH of 5.0. Again, if you consider that in the middle here is 9, then 5.0 is to the left. So we are going to have a +1 charge for the N-terminus end. Alright, now where is the N-terminus end on this peptide? Now we have to remember your notes. Remember what I said, by convention, on the left hand side you would have a free amino end, so NH3+. Alright, so it's on this end here. So valine's NH3+, so valine's amino group is free, and we say that's the N-terminus end. So the valine's NH3+, its amino group is free. Alright, so remember, alright, we have +1 for the N-terminus end at 7.4, and we also have a +1 charge at 5.0. So now we go to lysine. Now again, based on the table, remember these pK values are fixed values. Now according to what textbook you use, they might differ slightly here, but the idea here is that the pK values are fixed. Now the pK value for lysine is 10.5. So let's imagine that in the middle here is 10.5. So you have to ask yourself, where does 7.4 lie? Well, it lies over here. So you'd expect that at pH 7.4, lysine's R group will have a +1 charge. Let's see if it's the same for 5. Well, again, if the middle here is 10, 5 is less than 10, so 5 lies on this side. So once again, you would expect that the R group for lysine will have a +1 charge at the pH of 5.0. And we are correct. Excellent. Alright, so now we're going to be looking at histidine. That's the next amino acid residue in this peptide that has ionizable R groups, and the pK value for histidine is 6.0. So you have the peptide in part 1. The peptide is in a solution that has a pH of 7.4. So if this middle here is 6.0, it means that 7.4 is over on this side. So you'd expect that the charge of the histidine residue to be 0 at a pH of 7.4. Now let's look at 5.0. If the middle here is 6, 5.4 is on this side. So you would 5.0, sorry. You would expect that at a pH of 5.0 that the histidine, the R group of the histidine amino acid residue in this peptide will have a +1 charge. Alright, now just as a additional note, histidine, alright, now if you remember, there were 3 amino acids that have positively charged R groups. It's lysine, histidine, and arginine. And you would see that histidine's pK value is 6.0, while arginine and lysine is pretty high. So it means that at physiological pH, which is 7.4, pH 7.4 physiological pH, histidine, out of those 3, will have a charge of 0 in its R group. So something to remember. You might see it coming back up later. Alright, so you see 0 and a +1 charge there that we just calculated. Alright, we almost there to the end. So let's go to the next one, glutamate. Now the pK value, which is a fixed value, is 4.1. So we're doing, you know the drill by now. you're looking at 7.4, and you want to see if 7.4 is more than 4.1 or less than. In this case, 7.4 is more than 4.1. So your charge is -1. And similarly, for a pH at 5, again, if the middle here is 4.1, 5 is over on this side. So the charge for glutamate at both pH 7.4 as well as pH 5 is, as you would figure it out, -1. Excellent stuff. And lastly, we do the C-terminus end, same kind of drill. C-terminus, you're going from 0 to -1. Your pK value is 3.5. For part 1, your peptide is in a pH of 7.4. 7.4 is over on this side. So you expect that the C-terminus end will exist as COO-. And similarly, at 5.0, a pH of 5.0 is over on this end as well, and it's going to exist as COO-. So let's make sure we know where the CO- is. Alright, remember, by convention, your C-terminus end is written on the right hand side. So it would mean that that would be glutamine. Glutamine COO-, alright, or its carboxylate group is not attached to anything else. That's the end of the amino acid. So its COO- is the C-terminus end. Alright. Now all these other amino acid residues, lysine, alanine, histidine, and glutamate, their alpha amino groups and alpha carboxylate groups, they do not contribute to the charge of the amino acid because they are combined with the other amino acid to form a peptide bond. Alright, so again, you always look for the N-terminus end, the C-terminus end, and then you go through your question. Alright, there were 7 amino acids, those that had positively charged R groups, negatively charged R groups, and polar uncharged R groups, and they contribute to the charge. Any other amino acid that is other than the 7 of them, they will have a charge on their R groups of 0. So you find them out first. You find the ones that were not part of the 7, and you assign them a 0 charge. Then you go through systematically the others that were left. So you ask yourself, are they positively charged R groups? If they are positively charged R groups, well, then you're going from +1 to 0. Or if they are negatively charged R groups or polar uncharged R groups, then you're going from 0 to -1. Alright, so that's coming back to this C-terminus, and both of them will have a -1 charge. So we are almost there. We have calculated the corresponding charges to these groups. Alright, now we have to work out the net charge. And the net charge is easy to work out because now we have all the individual charges. All we do is that we add them up. And I always recommend to my students that you show the working. Alright, now you don't need to put in any zeros. They show the actual charges. Alright, so as you can see that at pH 7.4 you had a net charge of 0, and at pH 5.0 you had a net charge of +1. So always show the working, just in case you made a mistake somewhere along the line. At least when you show the working, you're getting marks, because we understand that you know that you have to add up these individual values. And guys, that's it, easy peasy. That's how you work out the net charge of a peptide. Alright, now something else since this came up. Alright, you see here that at pH 7.4 for this peptide, it has a net charge of 0. So it means that this pH value is actually very special. This pH value is actually what we call the isoelectric pH. Alright, or it's the PI value for this particular peptide with this sequence. So at pH 7.4 is also the PI value. Now let's get a definition for PI. PI, or the isoelectric point, is the pH. Now please include the word that pH. It's the pH. So like in the question before, that would have been the PI for that peptide was 7.4. So the PI is the pH at which an amino acid or peptide has a net charge of 0. Now I already have a video where I calculated the PI for amino acids, and I'll put that in the link in the description below just in case you want that as well. Alright, now as usual, I always give practice questions, so please try these 2 questions at home. Put the answers up in your comment section. Alright, and let's compare answers. I'm hoping that students will correct each other. Say, well, I think that answer is wrong, show alternative working. And then I'll come in and say, well, alright, this is right, this is wrong, and so on. And I'll guide you to your right answer. So give these 2 questions a try. And as usual, guys, if this was helpful, please like, subscribe, and comment. Appreciate the love. Thank you very much. Best of luck. Bye, guys.